So those problems where we are given a line and we're given a point and we have to figure out the slope of the line and take the perpendicular slope and then plug the point in to get the equation of the perpendicular line, then solve the system of the original line and the one we just found to get the intersection point, and then plug the 2 points into the distance formula. Those get kind of long and have a bunch of steps. So there is a shortcut formula, and today we're going to derive that. So you must, in order to use this formula, start out with it equals 0. Does not have to be integers. Does not have to be positive. But you've got to have something x plus or minus something y plus or minus something. The equals 0 is the key to it. And then we're still going to be given the point. So in order to do the derivation, not to use the formula, it's got to equal 0 to use the formula we end up with. To do the derivation, we do have to have it in slope-intercept form. So by equals minus ax minus c, and divide everything by b. And we have y equals minus ax over b minus c over b. That means the slope of the original line is minus a over b, and the y-intercept of the original line is minus c over b. What we really want out of that is to get the perpendicular slope, just like we do when we do it the long way. So flip it and change whether it's positive or negative. So our perpendicular slope is going to be b over a. Okay, now that we know the perpendicular slope is b over a, and we know the point on there, we're going to do like we've been doing when we've been solving these, plug the slope and the point in to get the equation of the perpendicular line. You usually used y equals mx plus b and plugged in and solved for b. On this one, since I'm sticking with x1 and y1, I'm going to plug it into my point slope formula, which is y minus y1 equals m, or b over a, times x minus x1. Then I need to distribute the b over a. Well, actually, I've already done that. I'm going to bring the y1 over to the other side. So I have b over a times x minus x1 plus y1. Now I am going to distribute the b here. So I have b, or the b over a. I have b over a times x minus b over a times x1. And if I want to get a common denominator, I could multiply that y1, because it's just a number, times a over a. Out of this, a and b were numbers in the original equation. They were the coefficients of the x and the y. x1 and y1 are numbers. They are the coordinates of the point. The only variable I have on this right-hand side is the x. So what I have is y equals b over a times x. And then I can do plus a negative bx1 plus a y1, both over a. That means this is my slope. This is my intercept for that line, but it is a second equation for my system of equations that I'm going to need to get the intersection on. Let me get this back on. Okay. So now we're going to take this equation, that's the perpendicular line, along with the original line, and we have a system of two equations. We want to know where those lines cross. We want to know what the intersection point is. I think it's going to be easiest to do this with substitution since they are both in y equals form. And this step and the next one are the two really messy ones, but then we'll be done once we get through that. So if I set these equal, I have minus a over b times x minus c over b, that was my original, is equal to b over a times x plus a y1 minus b x1 all over a. We know that when we have things with denominators and we want to clear those denominators, that we multiply by the least common denominator, which in this case would be AB. And if we do that over here, the b's are going to cancel, and we'll have minus a squared x minus a times c equals, and now on this side, the a's are going to cancel, so b squared x plus ABY1 minus b squared x1. And let me know if I've got any typos with exponents or subscripts or anything in there at this point. Okay, then what we want to do is we want to get the ones with x all on one side, the x that is a variable, which would be those two. All of the others, the a and the b and the c, are numbers, coefficients out of the original equation. X1 and Y1 are numbers, they're the coordinates of the given point. So I'm going to actually get everything on the right-hand side so that these can both be positive. So if I move the a squared x over to the right-hand side, it becomes positive, and keep the b squared x over there, it stays positive. Everything else I want on the left-hand side. So on the left-hand side, I'm going to have b squared x1 when it moves over. And then I am going to have minus ABY1, and I'm still going to have my minus AC. And you can probably guess when we're trying to solve for a variable, we're trying to get x right now, we're going to factor that out on the right-hand side so that this side is now x times a squared plus b squared. So to get just x, I need to divide everything by that a squared plus b squared, which means I have x equals b squared x1 minus ABY1 minus AC all over a squared plus b squared. And that is my x coordinate of the intersection point. Don't worry, the formula is not going to be that messy when we're done. We're still trying to get there. We're solving the system and we've gotten x. Our next step will be to get y. Is that what you were wondering about? Okay, so now to get y, we need to plug that in to one of our two equations in our system. I vote for the top one. It looks a little bit shorter. Is that good with everybody? So we're going to take y equals minus a over b times all of that, and then minus the c over b. So y equals minus a over b times this thing that we just found, b squared x1 minus ab y1 minus ac all over a squared plus b squared. And then our original equation next had minus c over b. Okay, I look at that and I've got a fractiony thing minus a nice little tiny fraction, but if I'm subtracting fractions, I know I'm going to need a common denominator. So I am going to multiply this one by a squared plus b squared over a squared plus b squared so that I have a common denominator. Then I am going to write out what in the world I have at this point. So I have that our y is, if I distribute, my denominator will be b times a squared plus b squared. That part's pretty easy. My numerator will be minus ab squared x1. Minus minus will be a plus a squared b y1. Minus minus will be another plus a squared c. And then I will have the minus c times the a, so minus a squared c, and the minus c times the b squared, so minus b squared c. And then look at that. Is there anything we can simplify? I sure hope so. Is there anything that'll cancel for starters? Evelyn? Wonderful. Let's let the a squared c minus a squared c cancel out. Then let's see if we can simplify any more. Is there any kind of a GCF in the numerator that I could factor out? My denominator is factored. James? So let's pull a b out of that whole thing. Or actually, to save a little bit of writing, I'm going to count, everything has one b, so I'm going to pull it out and then cancel it with the denominator. So I'm just going to have one left there. I'll get rid of that one, and I'll have one left there. Everybody good with letting me do a little bit less writing there? So then let's see, is that everything that I needed to cancel out of that? So what do I have left? I'm going to start with a positive one, I think. Y is a squared y1 from this one right here in the middle. And then I'm going to have minus, now it's just ab x1. And then minus bc all over a squared plus b squared. So now I have my y and my x for my intersection point. And they are admittedly very, very messy. So what I need to do is to take that x and that y and my original x1, y1 and plug them into the distance formula for my next step. So I already copied it down. You don't need to copy it down again. You've got it there in your notes. That's our intersection point, and the distance from there to x1 says that, and this is the last step of it, the distance is a big old messy square root, one of the x's, so the b squared x1 minus ab y1 minus ac over a squared plus b squared minus x1, comma, or no, sorry, square that, and then plus, now I'm going to subtract my y's, a squared y1 minus ab x1 minus bc all over a squared plus b squared minus my y1 and square that, and all of that is in my square root. Really, really long. Okay, fractions. So we need a common denominator. That's why I left the space there. I can multiply this by a squared plus b squared over a squared plus b squared. So I have a common denominator for that part. Same thing here. Question? Okay, we're getting there. Okay, that means if I distribute that x1 first, That means that I am looking at b squared x1 minus ab y1 minus ac minus a squared x1. It's a minus x1 I'm distributing, so minus b squared x1 over a squared plus b squared, all squared, plus a squared y1 minus ab x1 minus bc minus a squared y1 minus b squared y1 over a squared plus b squared, and that is also all squared. So we have a couple of things that are going to cancel, so that's going to start cleaning things up for us. B squared x1 minus b squared x1 will cancel. A squared y1 minus a squared y1 will cancel. And then let's see. Everything here has an a in the numerator. I'm actually going to factor that out as a minus a. So then it will be a minus a times by1 minus c minus a x1 over a squared plus b squared. And that's squared. And similarly, we'll factor the minus b out of this next part. Oh, I left my square root sign off on all that. Go back and get that in. What you're supposed to be helping me proofread for. Okay, now on this one, let's factor out the minus b, which will leave us times a x1. And you didn't raise your hands on my mistakes over here. Can anybody tell me my mistakes? Those should have been pluses since I factored a minus out. So clean those up there. So if we can do it right over here, everything should be positive when I factor a minus b out. So then that will be plus c and plus b y1 over a squared plus b squared. And that's all going to be squared. Anybody see any other typos? We've got the square root sign. We've got the squares on both parts. Okay, now I'm going to square everything. Which means minus a times minus a becomes a plus a squared. And I'm going to put this in the order of ax1 plus by1 plus c, and that gets squared. And my a squared plus b squared gets squared. Then I'm going to have plus. Minus b times minus b is going to be plus b squared. And then I'll put this in the same order, ax1 plus by1 plus c, and that gets squared. Oh, my denominator is going to be the same. It's going to be a squared plus b squared squared. So I'm going to go ahead and write that with a common denominator. Save us a little writing. Anybody notice that the long parentheses in the numerator is the same? So is it okay if I factor that out? So that I have ax1 plus by1 plus c squared times a squared on the left plus b squared on the right. And that's over a squared plus b squared all squared. And we're taking the square root of that. Anything we can cancel? Everybody see an a squared plus b squared in the numerator and denominator? So if we cancel the entire one in the numerator. We cancel one of the ones in the denominator. And that means that we have the square root of the numerator over the square root of the denominator. So square root of the denominator is square root a squared plus b squared. In the numerator, we have square root of a square, which may be ax1 plus by1 plus c. But if ax1 plus by1 plus c happen to be negative, and then we square it, it becomes positive, and we take the square root, we're going to take the positive square root because we know we want our distance to be positive. So we're going to call this the absolute value. Technically, square root of a square is definition of absolute value. And that, my friends, is your formula that you may use after I come around and check that you actually wrote this down, that you may use on future ones. But I'm going to go through an example with you of how this works and how it's nice and short and worth all this time that we just spent going through it. So if you want to write it down in formula notation, what this means is start equal to 0. And then this means plug the point into that equation. See how that's just plugging the point in there. And where students make a mistake, this is not from the point. Those are the coefficients of x and y that you square. So one quick example. Okay, I have y equals, I don't have anything equals 0. So first step is I need to change that. A half x minus y plus 1 equals 0. Or I could have done it minus a half x plus y minus 1 equals 0. Or I could have multiplied by a 2 to get rid of all the fractions. Any of that would be okay. That means the half is a, b is the minus 1, and c is the plus 1. You wouldn't necessarily need to write that down. Our formula says the distance would be, plug the point into that. So a half times negative 3 minus 5 plus 1, and take the absolute value of that. The denominator is the square root of a squared plus b squared, not the point, but the numbers in front of the x and the y. So the 1/2 squared plus the minus 1 squared. And I know the formula looked a little bit weird because of the square root in the denominator. We always clean it up for a final answer, but it's easier to have the formula like this. So that means negative 3/2 minus 4, so minus 8/2 in my numerator. Is that making sense to everybody? So negative 11/2. Absolute value of that is going to be positive 11/2. Excuse me. Or positive 5.5 if you'd rather do it with a decimal. Denominator, I'm going to have a 4th plus 1, so that's going to be plus 4/4, and I'm going to take the square root of that. So I have the square root of 5/4, and are we good with that's the square root of 5 over 2? So if I wanted to do it with the fraction form, I could multiply numerator and denominator by 2. 11 over root 5. Rationalize the denominator. 11 root 5. Excuse me, over a regular 5. Or root 5, 2. And I'd get the same thing.